Hello, ma'am. My name is Nandini, branch aeronautical. Today, I'm going to explain about wavelet-based usual visual analysis of data exploration. Introduction. Processing has emerged as a main alternative to analyze a single signals defined on the vertices of graphs. It focuses on adapting tools and operators such as Fourier and wavelet transforms to the context of graphs, opening a multitude of probabilities to the exploration and understanding of static and time varying phenomena in irregular domains. Similarities to the case of regular domains, most of the analysis derived from graph Fourier, GFT, and graph wavelet transforms release on the processing of coefficients associated with a certain basis functions defined on the vertices of a graph. However, the irregular nature of graph domains makes the coefficients sensitive not only to the properties of the signal under analysis but also the topology of graph. In fact, the topology of the graph directly impacts how the frequencies are spread in the graph Fourier domain, making the design of filters more intricate task. Filters designed without considering the distribution of frequencies may lead to wrong analysis and processing results. The conventional wavelet transforms is widely used in image and signal processing, where a signal is decomposed into a combination of known signals. By analyzing the individual contributions, the behavior of the original signal can be inferred. inferred. In this article, the authors present in introductory overview of extension of this theory into graphs domain. They review the graph Fourier transforms and graph wavelet transforms that are based on dictionaries of graph spectral filters, namely spectral graphs wavelet transforms. Then the main features of the graph wavelet transforms are presented using real and synthetic data. Data exploration. Data exploration is an approach similar to initial data analysis whereby the data analyst uses visual exploration to understand what is in a data set and the characteristics of the data rather than through traditional data management system. Data exploration is the first step of data analysis used to explore and visualize the data to uncover insights from the start to identify areas or patterns to dig into more. Using interactive dashboards and point and click data exploration, users can better understand the bigger picture and get a insights faster. This is the diagram how data is exploration explores. Data processes are divided into 5 types. One is univariate analysis, missing value, outliers, collinearity, and connection with data processes and data visualization. Data visualization is divided into three types: PCA, TS, NE, UMAP. Next, graphical displays of data such as bar charts and scatter plots are valuable tools in visual data exploration. A popular tool for manual data exploration is Microsoft Excel spreadsheets, which can be used to create basic charts for data exploration, to view raw data, and to identify the correlation between variables. That exploration allows for deeper understanding for a dataset marketing. It easier to navigate and use the data later. The better an analyst known as data they are working with, the better their analysis will be. Diagram of data. Similarly to the case of regular domains, most of the analysis derived from the graph Fourier, FT, and graph wavelet transforms relies on the processing of coefficients associated with certain basis functions defined on the vertices of a graph. However, the irregular nature of graph domains makes the coefficients sensitive not only to the properties of the signal under the analysis but also to the topology of the graph. In fact, the topology of the graph directly impacts how the frequencies are spread into in the graph Fourier domain, making the design of a filter a more intricate task. Filters designed without considering the distribution of frequencies may lead to wrong analysis and processing results. The conventional wavelet transform in is widely used in image and signal processing, where a signal is decomposed into a combination of known signals. By analyzing the individual contributions, the behavior of the original signal can be inferred. In this article, the author presents an introductory overview of the extension of this theory into graphs domain. They review the graph Fourier transform and graph wavelet transforms that are basic dictionaries of graph spectral filters, namely spectral graph wavelet transform. Then the main features of the graph wavelet transforms are presented using real and synthetic data. Data exploration is an approach similar to initial data analysis, whereby a analyst uses visual exploration to understand what is in a dataset and the characteristics of the data rather than through traditional data management systems. Data exploration is the first step of data analysis used to explore and visualize data, to uncover insights from the start or identify areas or patterns to dig into more. Using interactive dashboards and point and the click data exploration, users can better understand and bigger picture and get into site insights faster. Diagram of data exploration. Graphical graphical displays of data such as bar charts and scatter plots are valuable tools in visual data exploration. A popular tool for manual data exploration is Microsoft Excel spreadsheets, which can be used to create basic charts for data exploration to view raw data and to identify the correlation relation between variables. Exploration allows for deeper understanding of a data set, marketing it easier to navigate and use the data later. The better of analyst known as data they are working with, the better their analysis will be. Diagram of data exploration. Conclusion. The sensitivity of a GFT and GWT to signal area variation across irregular domains. These transforms gracefully combine the topology with the data under analysis such that they can be used to understand phenomena related to daily life. For instance, a homogeneous number of taxi pickups across the street map of a city suggests a large event happening in the city, while the more heterogeneous patterns can be lead to influential localities. Further, the temporal evaluation of data can be incorporated in the process in order to use GWT properties in spatio-temporal analysis. Graphical graphical signal processing it is still in its earlier days and much has to be done in order to make it accessible to inexperienced users for different fields as we have shown in the article. Many issues are still open, including how to change the edge weights to mitigate the impact of the topology in the graph. Fourier coefficients and graph wavelet coefficients. Other interesting problem is how to design filters with particular properties such as boundary detection filters, which could happen. Thank you, ma'am.